Okay guys, I wanted to make a video to show you how to install the programming environment that's called Processing. That's the one that Julie's brother Chris recommended, and I've been playing with it like I told you, and so I thought I'd give you some instructions and show you how to install it on your computer. So this is something that has to be installed on your computer, not on a pad or a smartphone. So open up a browser and go to download processing. You can see I've already been there, so let's go there, download processing, and you can see that you can download it for Windows or Mac, or Linux is another kind of operating system. I always have to look up if my computer operating system is 64-bit or 32-bit. An easy way to do that is to go up to the Start menu, find Computer, or it might be the name of your computer, and then right-click and go to Properties, and then down here it says System Type 64-bit Operating System. So you click on the 64-bit, and then it downloads the file. I've already downloaded this and installed it, so I won't actually install it, but at least I'll show you how to open up the zip file. What's being downloaded now is one zip file, but the zip file contains hundreds of other little files inside of it, so it's an easy way to transfer a whole program. And let's see. So I clicked on it, and it's showing me the contents of the zip file is this folder, but inside this folder is a ton of other stuff. You see that? So all you have to do is take this and then drag it to your desktop. Now, I've already done this, so I'll point to the location where I put this processing folder. It's already there, so I'm not going to drop it again. I'll just let go. Let's just pretend like I just did that, and but you should do it. And then when you do that, open up the folder and find the executable program called processing.exe. Right-click on it. Go to Send To, and then Send to Desktop to create a shortcut on your desktop to the actual program file that gets run when you want to start up. Now I'm not going to do that because I've already done it, and here it is down here, Processing. So let's open up that program, and the programming environment is here. If I really understood the programming language, I would type in some commands here, but I actually don't know it. So I just want to find some examples of programs other people have written. So if I do, let's see, processing, 2 examples, you can see once again that I've already been here before. And I like this one, Bouncing Bubbles. I checked out, and you can see the output. It's these balls that are bouncing. They're gradually floating down to the bottom of the screen. So let's go ahead and copy that into our programming environment. And I'll right-click, copy, then paste, and then we'll run that, see if it runs. Yep, there it is. Now, the neat thing about examples is that you get an opportunity to look at the program and understand how it does what it does. Now, it looked like from the output that the program must specify the number of balls. You see that here, numballs, and how much the ball should bounce when they hit each other, how much gravity should be there, pulling them down to the bottom, and then the amount of friction that they have when they rub up against another ball or the wall. Also, I see the size of the windows here. Let's make that much bigger. Make it much bigger. And let's make many more balls. Let's do a ton of them. And let's reduce the springiness, I guess. And let's make the gravity a little bit stronger. Okay, let's run that. There we go, lots of balls. You can see that they start out in random locations in the window, and at the beginning of the program, they're just let go, and they float down to the bottom until they bounce into other balls or the floor or one of the walls, and then they gain some motion in the X direction, in this horizontal direction. When they start out, they're just going vertical, then they bounce and start going left and right. Now, one of the things you'll notice is look at the small balls. The small ones are floating down to the bottom. And if we wait long enough, you'll notice that all the small balls are at the bottom, but very few of the big balls are at the bottom. And the reason for that is because it's easier for the small balls to fall in between the gaps between the big balls. And take a look at it now. You already can tell, right? Small balls are at the bottom. So let's go ahead and stop that. And you notice I'm doing play and stop here. You could look at the rest of the program and figure out what these other commands do. It looks like here's where the balls are defined. And they're defined with random widths and heights. That's why there are big ones and small ones. Don't know what this 30, 70 does, but I'm sure I could figure it out if I were to look up the syntax for this ball command. I bet this is defined down here. Yeah, here it is. Oh, I see. I see. Let's see. It looks like this is initial velocity in the x direction and y direction, and the initial velocity is 0. What that means is the balls at the beginning are just let go right where they're placed, and the reason they move at all is because there's gravity pulling the ball down. But you could change this and define that they start out with some velocity in x or y or both. I'm not going to do that now, but that would be fun. I suggest maybe you try that. I think, let's see. Yeah, I'm not sure if you would put a number here or put a number here. Again, I'd have to play with that. Okay, so let me not do that. But down here are Newton's laws of motion. You could even play with physics and change the way physics works by modifying these laws of motion. Feel free to change anything you want. You can't break your computer, and that's one of the best ways to learn software. Just change some stuff and see what it does. Okay, enough of this. Let me go on to a different one. And that's another one that has sort of a cool looking... oh no, I want examples. This one, reach, I like that one. So see this one? It's pretty cool. It's a spindly little thing. And let's take a look at the code that makes it. Oops. Here we go, down to the bottom. Right click, copy, paste, and let's run that. And here it is. It made this window. And look, you move the mouse and you can make the tip of the spindly thing move around. Let's see what the settings are at the top. Oh good, number of segments 10 and segment length 26. So I bet segment length is the distance between the joints. The number of segments tell you how many segments are. Let's change number of segments to 30, and let's make the segment length bigger. Let's make the window huge because now it's going to be very long. 1800. We'll make it by 1000. Let's take a look at that. You always have to stop it before you can start it again. Oh, look at that. Here it is. Pretty cool. So the computer right now is running that program, and that program is, I haven't looked at it, but I guess it's in a programming loop, an instruction loop, that continuously looks for the location of the mouse and then recalculates where the spindly snake should be drawn. So let's go ahead and stop that. Again, I see a lot of interesting commands that I might want to research, like this stroke command, I think makes the color and the transparency of the segments. Lots of other cool stuff. But I'll just stop right here. So let's end here. If you have any problems, let me know. And then afterwards, we can get together and talk about this and maybe do another project. Bye-bye.